This is AS Mechanics, paper 4, 2, October, November 2021. Um, question 6. Okay. A block of mass 5 kilograms is held in equilibrium near a vertical wall by two light strings and a horizontal force of magnitude x newtons. The two strings are both inclined at 60 degrees to the vertical, and they're saying if x is 100, then find the tension in the lower string. So we have this box. It's being attached to two strings, so two tension forces acting to the left, and it's being pulled by a force x, which puts it into equilibrium. Okay. Just so you can understand, we increase the value of x so that we could put it in equilibrium. And it's being resisted by two forces, right? So we want to find the tension in the lower string. So I'm just going to call this one here T2. Sorry, I'm going to make this a bit thinner. I'm going to call this here T1, and I'm going to call this one here T2. So let's draw the FBD for our block over here. So it's going to be, this is our y-axis, and this is our x-axis over here. So we're going to start first with the weight going downwards. We're going to start with our x going to the right. We also have two forces. We said we're going to call this one T1. We said we're going to call this one here T2. They both have their respective x and y components. This would be T1y. This one here would be T1x as well as T2x. Okay, and this one down here would be T2y. Okay. Let's figure out the angles. If here it's 60, that means the angle over here will also be 60. But to make my life easier, I'm going to use 30, right? If you draw the horizontal like this, the vertical like this, the angle over here would be 30, obviously. Because here it's 90, right? 60, 30, 90, and since they're both the same, so here also it will be 30 degrees. Okay. So over here, between our horizontals, we're going to have 30 degrees. And over here, 30 degrees. Okay, so now let's resolve. We know, let's start with sigma fx. It's equal to 0, right? Okay, that means all my horizontal forces are equal to each other. All my horizontal forces on the right are equal to all my horizontal forces on the left. On the right, I have x, and on the left, I have T1x and T2x, right? So T1x plus T2x. X, we said, is equal to 100. T1x is going to be equal to T1 cosine 30, and T2x is going to be T2 cosine 30. Why cosine? Because I'm looking for the x component, and I have the angle with the horizontal. So this is, we can call this equation 1, okay? Our second equation, we're now going to do sigma fy is equal to 0. So all my vertical forces on top will equal all my vertical forces on the bottom. So T1y is going to be equal to T2y plus W. So let's solve this a bit easier. T1y would be equal to T1 sine 30, right? So T1 sine 30 is equal to T2y, which is what? T2 sine 30. Sine, because the angle is with the horizontal, and to find the y component, you multiply by sine of the angle. Okay, plus W, which is equal to mg. We can substitute a bit more, so we're going to get T1 sine 30 is equal to T2 sine 30 plus mg, which is the mass 5 times 10. And then to substitute one last time, you're going to get this, okay? Plus 50. So we now have equation 2 and equation 1. We can find this very easily. Let's find an expression. They want the tension in the lower string. So we can find an expression for, look, we said the lower string is T2. So let's find an expression for T1. Because when you solve, if you find an expression for T1, it's going to get cancelled out. Okay, and we don't want to get cancelled out. Sorry. If you find an expression for T2, you can say T2 is equal to something. It's going to get cancelled out. You're going to cancel it out here, right? And we don't want it to cancel out. We want our final answer to be T2. So for that reason, I'm going to find an expression for T1. It doesn't matter, but just to make my life easier, just take anything. I define T1. An expression for T1 would be, take T2 cosine 30 to the other side. It's going to be 100 minus T2 cosine 30 over cosine 30. Because we took T2 cosine 30 to the other side and we divided by cosine 30. Okay, so this is T1. So over here we can substitute T1 by 100 minus T2 cosine 30 over cosine 30 times sine 30 is equal to T2 sine 30 plus 50. Okay, we can cancel sine 30 over cosine 30. So it's going to be here, we're going to continue, 100 minus T2 cosine 30 multiplied by tan 30 is equal to T2 sine 30 plus 50. Okay, from here, I'm going to distribute tan 30 inside here, okay? Because I want to solve this equation. I have T2 on both sides, so I actually have to distribute, right? So 100 times tan 30 is just going to be, let's just keep it in terms of tan 30. Let's keep it in terms of tan 30. Okay, we're going to get 100 tan 30. I don't want to use a decimal and approximate because I'm going to get a wrong answer. Tan 30 times cosine 30, I don't know how much is that. Tan 30 times cosine 30, 1 over 2. Okay, so tan 30 times cosine 30, so it's going to be 1 over 2, so 0.5 T2 equal to T2 sine 30 plus 50. Okay, T2 sine 30, by the way, is equal to 0.5 T2. Okay, because sine 30 is 0.5. So you're going to get 100 tan 30 minus 0.5 T2 is equal to 0.5 T2 plus 50. So you're going to get, solve this equation, take 0.5 T2 to this side. You're going to get that 100 tan 30 minus 50 is equal to 0.5 plus 0.5 is T2. So you're going to get T2 is equal to 100 tan 30 minus 50. 7.73, whatever. We know in the exam instructions that we're supposed to put all answers to 3 significant figures. So it's going to be 7.74 newtons. Okay, this is the lower string. Okay, find the least value of x for which the block remains in equilibrium in the position shown. So this one really took me a while to understand, but basically over here, x is balancing out 2 forces, right? It's balancing out this force here and this force here. Obviously, to decrease the amount of x needed to balance out the forces, I would have to decrease the forces over here. So you would ask yourself, the least amount of force I would need to balance out is if instead of having 2 forces, I only have 1 force. So if you ever come across any question like this in your AS or in your periodic, for those who are doing, who are watching this for the SABS system, if you watch this for the AS, I don't know, like if you see this in your AS, always think it's always easier to balance out 1 force instead of 2 forces. So we're going to resolve our forces, okay? We're going to use actually the same equations from part A, that x is equal to T1x plus T2x, and T1y is equal to T2y plus w. So I'm going to start by saying that. I'm going to start by saying sigma fx is equal to 0. Just copying down what I wrote earlier. So x is equal to T1x plus T2x. And sigma fy is also equal to 0. Don't forget your vector symbols. So it was T1y is equal to T2y plus w. Okay, and we said that x is equal to, continue it, T1x we said was T1 cosine 30, and T2x was T2 cosine 30. Over here, T1y was T1 sine 30, equal to T2 sine 30 plus weight, which we found was 50. Okay, so we got these. So the least amount of tension required for x is always achieved when either T1 equals 0 or T2 equals 0. You're going to say, Walid, how would you know which one is 0? So you're going to assume both assumptions. You're going to take 2 assumptions. And honestly, it makes sense that t. Actually, no, I'm not even gonna try thinking about it. We're gonna just take both cases and assume, and I'm gonna show you why t1 cannot be equal to 0. Let's first try case 1, and we're gonna call it. Credits to Zuha, because I saw her solution for this. I honestly wouldn't have known it with if she didn't write the solution. I was stuck on it. Anyway, case 1, we're gonna assume that t1 equals to 0. If t1 equals to 0, you're gonna get two equations. Okay, the first equation is that x is equal to t2 cosine 30, right? And the second equation would be that t2 sine 30 plus 50 is equal to 0. This obviously would be rejected. Some people would still be like, oh, why? Man, look here. Can you ever have a force plus 50 equals 0? Okay, so basically what we're trying to tell you, yani what I'm showing you, is that t2 sine 30, if you take 50 to the other side, it's equal to negative 50. Can you have this? Can you have that sine is equal to a negative answer? You cannot. You cannot, right? So, for that reason, this one is rejected because you're getting that t2 is equal to t2 sine of an angle is equal to negative 50. That's rejected. How about now if t2 is equal to 0? We're going to get that x is equal to t1x. That's as our first equation. And as our second equation, whoa, that's horrendous handwriting. That's our first equation. And as our second equation, t1y is going to be equal to 50. Over here, I'm copying this one. And this is completely fine. This is completely fine. I'm not going to write t1y. Actually, I'm going to say t1 sine 30. It's better. t1 sine 30 is equal to 50. This is completely fine. This is accepted. Right? This is accepted. Remember, what are we asked to find? We're asked to find the least value of x. So we're supposed to solve for x, right? So let's see. X is equal to t1x, but I need to find t1. I know that t1 sine 30 is equal to 50. So we're going to write first. Let's solve this. We can obviously find t1. So t1 is just going to be equal to 50 divided by sine 30, which is equal to 100. Okay? Therefore, x is equal to t1x. Therefore, x is equal to t1 cosine 30, right? I should have written it like this from the start. Therefore, x is equal to 100 cosine 30, which if you do on your calculator is 50 root 3, which is 86. How much? 86.6 to 3 significant figures. Okay, 86.6 newtons. There you go. Oh, actually, no. No unit, right? Yeah, because it already has a unit. Okay, so we're going to keep it as 86.6 only. Let's check the marking scheme. 86.6. So you'd get 1 mark for resolving these two forces. You'd get 1 mark for this. Let me see. Write it in blue. You'd get 1 mark for this, 1 mark for this. I think 1 mark for finding T1. Yeah. Okay. And then basically you'd get 1 mark for this, 1 mark for this. So all of this here al-fadi, this has nothing, but obviously you need to do this to get to this step over here. I should have written a nice 2 over here as in step 2. Okay, so that's it for this question 6. Thank you so much for watching, and good luck.